Hello everyone. How are you all doing? I hope my voice is loud and clear. Thank you. So here we are. I think we are at the end of the fag end of our journey, and we said on last week, right, that we will go through problem statements that you might have, and if you are interested, we can look at other parts of the things, right? Shall we start with the project? Did any of you attempted the projects that was assigned? We spent quite a bit of time on the project, remember, on Friday. And if you guys have any specific question on the projects, maybe we can start with that. In fact, let me quickly share my screen and go through that. Today is nothing. Just let me just quickly share my screen. What did we? Yeah, I think what we did is that we went through the project, right? The whole project plan. Some of you wanted a checklist, and we spent quite a bit of time on doing building the checklist. This is actually good checklist to follow if you can all follow it. Did anyone was able to start the project? Do you have any questions that you think that is worthy of discussing now? Today's session is mainly because there is no agenda. Essentially, this is the last of the session, right? So what we can do is that we can go over parts of the parts of the codes that you might want me to revise, okay? And yeah, anything basically. It's basically an open-ended discussion today, and broadly Q&A. And I think that this is on the quiz, okay? Okay, I'm just heading over to the quiz live classes. Can you please tell me? So the quiz essentially is which part? This is Ocha, okay. You are talking about so the first one doesn't have any quiz, I assume. Okay, the assessment part. Let's go to the assessment part. Okay. So the simulation test paper, is it? One and two? Is that the? Yeah. There is a simulation as yes. Okay. Yeah, so there is one simulation, and there is another one which is a real one. So you can actually start with simulation, but the grade both of them are graded. Sorry, one of them is graded, right? If I'm not wrong, the test two is graded. Yeah, please go ahead. What is the question that you want to ask? I cannot start the quiz, then probably you will see my questions. Hence, you know, please go ahead and ask, Surya. Please go ahead and ask. What is that you want to know? How to prepare? Okay. Right. How do you prepare? Okay. Yeah. So I think this quiz is about I would if you want. So this is going to be a time limit, right? So you probably will not get much time to you know search for an answer, right? If I wanted to understand your question. So I think maybe go through all the go through all the questions. It's gonna be implementation. Yeah, yeah. It's gonna be theory. Yeah, yeah. Theory. Mostly theory. Yeah. That's the reason you should take the simulation test paper once, and it's mostly theory. Okay. You might be asked to, you know, like a question like this, right? This is I don't think there is any code, if I'm not wrong. Okay. There is not much of a code, but it's mostly multiple choice questions. Okay, if I'm not wrong. Okay. Have you looked at the guide section? There is a guide section, right? If you just go to self-learning, there is a guide section which tells more about it. But I don't think there will be any code that you have to write because it's a timed quiz, right? 1 hour, right? And for the coding thing, you have anyway 3 projects to work on. So quiz will be fun in the sense that you will have very short time to analytically understand the question and answer to it, and sometimes you just have to know the answer, right? So typically the quizzes like that. Test one is simulation. That's correct. Yeah, that's the reason it has been given long R, and the actual the one is fairly small, right? So 30 questions, which is half of it, right? And you don't need 1 hour actually. Okay. 30 question 1 hour means what? Like you can imagine, right? It's like one question 2 minutes. You don't need one question 2 minutes if you attempt it properly. Okay. Right? Did anyone start the PET classification model using CNN? Hmm. Okay. You are able to get good classification? Were you able to get good results out of it? No? Okay. Do you want to share? Okay. Did you do any kind of you couldn't find acha. What was the problem? Were you able to find out what was the problem? Are you loading the data properly? That is more important thing, okay? Many a times what happens that your data might not be loaded properly because they are not in the same folder, okay? If you remember the data, yeah, I think ensure that your data is loaded properly. This specific project, the confusion will not be in the layer because the layers have been given to you. 3 layers, right? You just have to put the right things at the right place. But since the data is not very typical, right? It is in distributed in 2 different folders and all. Ensure that part is very clear. Or else you might actually not load information and then expect the model to perform good, which is might not be good actually. Yeah? What is the confusion in your fully connected layer? Can you explain what is the confusion? Maybe I can help you in that. Okay. Is there any fines? Should I just in your community link? Okay, just 1 second. Let me just open the community link. This is the one. This is the one. Okay. Um, compile its more, but running the model. So I don't see any. This message is awaiting is awaiting moderator approval. It seems. So your message is not what do you say? Is not approved. So I haven't got any. None of us have got this actually. And we have. I can't see your Jupyter notebook. Can you put what is the error that you are getting here in the chat box? If you can put what is the error that you are getting, it will be easier. Well, there is also another question from Uttam. Okay, which is that um, you wanted to understand. Can you say which outlier treatment will be good decision or not? Okay, is this problem solved already, or Uttam, is this problem solved? Were you able to solve this problem? Confused now. Okay. What's your confusion? I am applying, okay, you are applying a machine learning model to I'm not able to understand. What are you applying machine learning model on? This is this is this okay? This is a machine learn. So this is a different problem statement, right? Or yeah, this is a different problem statement. Yeah. So yeah, so could you suggest outlier treatments will be decision? Yeah, treat outliers if you have a good strategy to treat outlier, please go ahead. But what can you? So this is so let's see what is the feature that you have. You have a feature of class. Outcome is how can you do you think that you can treat outcome via sorry outcome via insulin level? Acha, the feature is insulin level, right? So now the thing is that what will you treat an insulin levels as an outlier? If someone's insulin level is 1600, that's a real fact, right? So there are many cases, and it's not that bad, right? It is not, at least in this graph, this is not that bad, right? So there will be people who will have outliers, and you have to handle your machine learning model has to handle outliers. Any model has to handle outliers, right? So I think you should just I mean you can what will you do you have a strategy to do that? What is your strategy to handle outliers is what I'm asking. You do you want that particular person's insulin level to down, or you have to increase some of the other samples, right, up, right? Or you have to add pseudo samples or upsample them, right? These are the only few ways to do it, right? So again, the fact of the matter is that you're not doing statistical measures. You have been trying to create a model. I'm assuming a healthcare model where your precision or your recall, something has to be very high, right? It has to be very, very high, right? You can't have failure cases. So I think you will always have class imbalance in some case, and insulin, yeah, this is fine. I think you should be able to build your model. Okay, so Suchita says that you are using sparse categorical cross entropy, okay, with logits. So now, which means that so logits and labels also have the same dimension. So you have separated the logits out, is it? So what is logits? Can anyone tell what is logits? This is an interesting topic. Logits is the outcome of. Do we understand what is the difference between logits and label? This is a generic machine learning question. Sorry. Logits are what? Do you remember? And why are you using sparse softmax cross entropy with logits in a CNN model? I think we could just use the. I mean, you can use the. So let's come back to the CNN. Okay. So this is a 10. This what? How many now? How many classes are there? Oh, this is pet and dog. So there's two classes, right? So you can use softmax as it is, right? But do you need to use a sparse softmax? So you just use the last, is it written that you have to define the loss function? Okay. So if you just use the softmax, can you as a change just use a softmax? I think what you have done probably is that whatever you are using the logits and then so logits is the actual value, right? Just before, so logits is an input to a softmax function. So the loss function that you are defining does not give you probability. Okay. So that is one of the reason I think that's what you're doing. Okay, so this is does not give you the probability, it gives you the values, and logits are an input to the softmax function. Remember that, okay? So whatever the output layer gives you, and just before the between the aggregation and that thing, yeah. So just use for loss, just use categorical cross entropy. You have two classes, right? Just use categorical cross entropy and try to see whether it solves your purpose or not, and check whether your model performs better or not. Use categorical, remove the loss equals to categorical underscore cross entropy. Can use that, okay, and try to see whether it helps in your model or not. Use something like this, okay? Loss equals to categorical underscore cross entropy. Okay. So this will use the class called as categorical cross entropy, right? That's what if I'm not wrong, right? So if you actually see this, I think that the default implementation is, let's look at TensorFlow, okay? Let us look at TensorFlow. Oh my God. Yeah, so if you use the one that I have given you, so it will use categorical cross entropy and the output will nothing but be a label. So it will take the output of the aggregation layer of the last aggregation operation of the last layer just before passing to softmax, and then do the give the output level properly. Okay, so you can use this thing. Okay, use this and check. This is only 2-class problem, so you should be able to handle it. Any other question, folks? The issue probably might be with this. Are you able to run 100 or 200 iterations? I think this is where your infrastructure problem might hit. I was actually curious to know that if anyone was able to run 100 200 iterations. It will be good if anyone can find a way to run it. And this will require you to, I think if I'm not wrong, yeah, I think it might take some time, but you will realize that training machine learning model is a lot of wait time is there. And since you will be doing on CPU, it will be more. So Suchita, just use this thing and try it out. This should alleviate your problem. Okay, if you have just used the layer as in which, then just use the categorical cross entropy object, the class, and it should give you a cat or a dog. Okay, either one of that. Okay. Any other question? Lending data. Anyone able to finish lending data? What is the result that we are getting? Or even for the house loan data. Uttam, you were able to finish it off? What was your accuracy? Can you share with us what was your accuracy as a final model? Okay, no worries. Yeah. Okay. Any questions? So we said that we will actually look at all these things, but I leave it to you guys. If you guys want to do it, we can go over each of them. And I definitely don't want a monologue for this session. I wanted a dialogue kind of a thing. Please ask me if you have questions, and then maybe So there was a specific question last year, right? Someone asked me what is the difference between. No, I totally forgot. What is the difference between ROC curve and AUC curve? Okay. Um, so do you want to go over it? Maybe we can start with that. Yeah. So what is your understanding of ROC curve? I made this thing that day. So basically I copy pasted it from somewhere. It was already there in one of my explainers. So all of us, okay, all of us are clear about the confusion matrix? Everyone knows what is the confusion matrix? In the world of classification, what is a confusion matrix? How? So what is the confusion matrix defines? How will you explain a confusion matrix? No, but what is a confusion matrix? So the precision, recall, and accuracy, you get an output of. Once you build a confusion matrix, you can build all these things, isn't it? Because you need those numbers to build a grid of all possible outcomes. Perfect. Per class, right? So how many if you have 15 classes, how many confusion matrices you will have? Ideally? I mean, you will definitely have one confusion matrix, but you will have values for each of those classes. Remember that? So technically you might have, you will have each row of one confusion matrix or confusion statistics for each class, isn't it? That is something that we have to understand. Now, yeah, number of correct versus incorrect predictions made. So let us be very, very clear about confusion matrix, right? So this is what a confusion matrix looks like, right? Oops, sorry guys. So this is what a confusion matrix looks like. Do you remember? Right? Whatever you want, once you are trying to project versus the correct and incorrect prediction, or in fact correct, whatever your true versus whatever you predicted, right? In that there are four possibilities, and there are only four possibilities. This is true for any classification, right? Your diagonals, one set of diagonals will represent true positive. What is true positive? We are clear about this nomenclature, right? What is true positive, false negative, true negative? I'm assuming that you guys are all clear about it, okay? So now the question is that for a classification use case, how did we even arrive at this? How did we even say that a class is some probability of class? Internally, the model, right? When it was changing from logits to, um, interesting. We discussed logits. When it was changing the logits to probability, it must have put a threshold, right? Remember, the internal threshold generally always is generally 0.5, isn't it? If a probability of a class is above 0.5, mark that class as true. If that particular class probability value is less than 0.5, mark that class as not true, right? So this we are clear about this part, right? Everywhere you have where you are passing some value and then you are estimating a probability, and then from probability when you are saying that this is this level or that level, right? Level is what? Whether it is cat or dog. You have to say you have got a probability of 0.55. Now you have to say whether it is cat or dog. How will you say it's cat or dog? So you will say because the cat's probability is more than 0.5, hence you will say it's a cat, right? You have to mark that prediction for that particular test sample, isn't it? So now to mark that, we need a threshold, right? And internally, generally, we say that 0.5 is a threshold, isn't it? But how do you know it is? Are we clear about? Do we understand this part? Are we understood, right? That wherever there is a classification from transforming from probability to a level, we need some sort of threshold, isn't it? You need to build a threshold, right? And you have to mark that threshold. All of this, all of this, will actually do that, right? All of the accuracy metrics will do that. Agreed? Are we on the same page, folks? I'll move from there if you guys give me some yes. Yeah, right? But the thing is that in the case of this insulin case that that some showed us, it might not be true for no, point 0.5 is not a good cutoff, right? You might say that I need a higher cutoff, or in some cases it can be a lower cutoff, right? So how do we know what cutoff that I have to do? Basically, when I'm transforming from, yeah, so your shapes are not incompatible. This is a classic case. Then that means your shapes, your data load is not proper. Okay, let's look at that. Let's look at that. Okay, maybe we'll have to look at that in a deep. We'll look at that after this explainer. So now the thing is that coming back to this ROC curve, we need to manage the thresholds. How do we know that 0.5 is the best threshold for us to determine or put a label from a logit function, right? So that is something that we have to do. So for what we do is like we take for every new value of this threshold, maybe you start with we will have this confusion matrix, right? This confusion matrix will change, right? If you change this threshold from 0.5 to 0.2, confusion matrix values will change, isn't it? Yeah, it's going to be from the all the probability value, right? It's a value between 0 and 1. If you put a very high threshold, it's a threshold of the probability. If you say the probability of point 0.9 and above will be, if anyone's point 0.9 and above will be that particular class, right? It depends. This is the normal statistical measure of putting point 0.5, right? But in many cases, we don't need point 0.5. How do we know that point 0.5 or any of this threshold value is the right thing? ROC graph actually helps us to do that. So for every new threshold value, you will get one thing. One thing is your test accuracies will change, right? All your accuracy metrics will change, which essentially means your confusion metrics will also change, right? Isn't it? Because your true positive will change, your true negative will change, right? If you have a higher threshold, you will have you are putting a very stringent effort. You want to be 100% sure before saying that someone is diabetic, almost like, right? If you have a lower threshold, you are saying that you are okay. I mean, just if barely if it goes above point 0.5, say that it's a true, it's cat, whatever is your main class is, right? Whatever is your class distribution is, right? You can say something like that, right? Isn't it? So that totally depends on your business criteria. So for every new value of this threshold, you will have different confusion metrics, right? So what you do is like ROC curve, nothing. ROC curve basically graphically summarizes the info. Think about that there is a lot of confusion metrics as possible. Is it possible for you to actually build so many confusion metrics and then summarize them and check, find out which is the best thing? It is impossible, right? Because there could be many different kinds of values. Someone will say, no, why not 0.55, 0.23, 0.9, 0.82? There's no limit to it, right? So you can have almost infinite number of threshold values, because but your threshold value is from 0.1 to you know point 1. It's going to be between 0 and 1, right? So ROC graph helps you to draw all this confusion matrix and summarizes the information in such a way that you can take a best call. So how it does it? In your X column, you you put something called a specificity, and your Y you put something called a sensitivity. What is specificity? Specificity is that 1 minus true positive divided by true positive plus false negative. Okay, this is nothing but a race part. What is specificity? It basically tells what proportion of my non-C class, or if your class you're trying to predict is, suppose you're diabetic, what is the proportion of my non-class samples is incorrectly classified. So it's like it is saying that how much specific you are, and your y-axis essentially is what proportion of my class is correctly classified. So based on this, you put values, okay? So it can be only from 0, 0 to 1, 1. It cannot be any other value whatsoever, right? That's not possible because this is a probability estimate. So you will draw a graph, and the graph which has highest specificity and highest sensitivity, right, generally wins, isn't it? So basically, you want specificity to be as close to be 0 as possible, isn't it? You do not want. So that again depends on your business condition. But mostly we want non-C class to be not correctly. We don't want any incorrect classification generally. So you will arrive at a value and you will see that, okay, this is my best threshold value, and then you will rerun your accuracy estimate based on that again. Okay, so that is what it is. But most of the time you will see that in case of this healthcare and all, instead of specificity, you use precision as your x-axis. This is something that I have seen a lot. Okay, so they will use an ROC curve. Okay, but in case of this x-axis where you have specificity, basically this is specificity. It's 1 minus specificity. Okay, specificity formula is true positive divided by, this is not actually, this is a rate. Okay, this whole thing is called as a rate. I don't think this is recall. So this is the false positive rate. and this is the true positive rate. You are trying to find out a ratio between your true positive versus your false positive. Okay, and that is what you want to do. Okay, and this is only between a 0 to 1. Your objective is to find that best threshold which describes my accuracy best. Again, right, if based on what you want. So again, many cases, precision is something that you are looking for, right? You want lot of places precision, right? You can also, precision is something that you can look for. So that is exactly, this graph is called as ROC graph, to find out the best threshold. Okay, that is what it is. Okay, what is AOC? ROC is there's a what was the what is the full form of ROC? It's actually very. Do you remember what was the full form of ROC? Let's look at it. Receiver operating curve. That's correct. Yeah. Receiver operating curve. And AUC is nothing but, intuitively, if you actually have multiple ROC curve, right? AUC, but which means that you will have, but what it signifies? It signifies which ROC is better. Okay? You will have multiple ROC curve, right? It's possible that you will have multiple ROC curve, right? Why will you have multiple ROC curve? Okay. Why do we have ROC curves? Because we are trying to find out best thresholds. But suppose one more ROC curve comes here, okay? But tell me, can you tell me what is the two? How can I have another ROC curve? How can I have a different, totally different? See, one classification evaluation will give you one ROC curve, right? How is that possible that I'll get one more ROC curve, totally different? No, threshold adjustment, no. You will not. Even if you threshold adjust, right? So if you adjust the threshold, it will come here. You will not get a different ROC curve. So you same ROC curve. So these boxes, these points are nothing but different thresholds. Okay. So different thresholds are nothing but ROCs. But so different thresholds are actually put on top of one curve. The reason you will have different ROC curve is because if you are using different algorithm altogether. Suppose this first ROC is from linear regression or logistic regression, sorry, and the second one is from SVM. So how will you know which one is better? That's how you will have, first of all, you will have two different ROC curves because your method to measure or your your learning algorithm is different, right? Hence, it's possible your threshold will be also different, right? So that is the reason you will have different ROC curve. And how will you know which one is better? That is that is where you use this AOC. You will find out that you will draw a line here, right? And you will find out which area has a bigger one. Whichever one has a bigger, go with that algorithm. If you go with that algorithm, and in that, find out the best threshold, which has the less specificity, but the highest true positive rate. Right? So curve, the AUC will tell you which ROC is best. ROC generally represents a algorithm's output. Once you actually freeze on the algorithm, you now have to find out what threshold works best for this data, right? And ROC will actually point multiple thresholds, and you will try to find out highest sensitivity or TP rate in this case, right? Your true positive rate versus lowest false positive rate is something that you can take and go with it. So basically, you got both of your objective covered. Okay. Sorry. Are we on the same page, folks? We said we will do backward propagation. Anyone is interested to backward propagation? It will take me, 15 minutes max. I think so. But if you guys are interested, then I'll go, or else I'll not go. Okay. But okay, fine. So I saw 2 years. So are we on the same page on the AOC and ROC? Are you able to understand? Are you able to understand? If you have been asked to actually evaluate two algorithms, you will actually start with an AOC curve. But for an AOC, you need ROC, right? and then that's also one easy way to understand your various classification model, which is good, which is not good, right? And also it gives you that threshold, which is the best threshold that you actually thought are the best. But there are, right, you will have, right? So your cross validation will give you, if you run a cross validation, and 90% of the time you will run, right? So you need to know which is my best this thing, right? Which is my best algorithm for this particular data set. So that's how you used to, that is what we have to do, right? In most of the cases, unless there is a one model which is outshines everything by a large margin. Okay. Shall we do a little bit of back propagation? We will just continue with wherever we are. I mean, if you guys say I didn't catch up with, are we ready to do it, or let's do it actually? Okay, yeah, please. Okay, let me just try to find out where did I put it. Yeah. So the same explainer. Remember, let's set our ground rules. What was our ground rules? Do we remember our sample neural network? We had, four samples, x1, x2, x3, x4. Okay, literally four samples, and we have how many layers are this? This is how many layers, folks? How many? So this network has how many hidden layers? This network has how many hidden layers? Three. How many output layer? One output layer. Okay. How many classes? We have, it's a multi-class or multi-level or single class? Okay, it's 3, 2, 4. We have everything now. Okay, so 2 is the class. So fine, got it. Okay. So is it a multi-class problem or a multi-level problem or a binary class problem from this image? I'm just trying to set up the context. It's not a binary class, right? It is, I have clearly said, class 1 and class 2. So there are literally two different class, right? If I have multi-class, then what activation function can I use here? Some sort of, can I use sigmoid here? Can I use sigmoid here? Why can't I use sigmoid here? Fine, yes, correct. We can't use sigmoid here. There's a reason. Why can't we use sigmoid here? We can use softmax. We have to use softmax or some variation of softmax. But why can't we use sigmoid? We have gone through this. Sigmoid gives me, yeah, in that way it is fine. I want you to little bit become a, formulate it in a way that we discussed last time, I think. Sigmoid gives you independent distribution of probability, right? So class 1 will be evaluated on its own, class 2 will be evaluated on its own. That is not what you want. You want either one of that, right? In this case, so if you use sigmoid, you can use sigmoid. Nobody is stopping you. Only thing is that it is not a conditional probability of either on that. It is both. It will be evaluated on its own, right? So this will become a multi-level classification problem. In this problem, what we are seeing is that, so it can be only one class, right? So I have to use, and softmax uses an aggregated dependent probabilities, right? All across the probability of all class 1, class 2, class 3 will be sum to 1. So that's a very distinct differentiation between these two things. Remember that very, very well. Okay. Okay. So now that we are machine learning trained, sorry, not only machine learning, we are neural network trained, right? So this is not a problem at all. What is our forward path looks like? Are we able to appreciate this image? If just go through this once before we start our backward calculation, and we will see that why we have to calculate so much. So I have one feature, okay? I just said x1, x2, x3, x4. Similar, yeah, no, little bit different, but similar. So soft argument max is what? It's little bit it's little different, but it's not exactly same. Okay, argmax gives you what? The position, right? Remember, n argmax gives you the position in the index. Okay, so let's look at this network forward pass once. Okay, so I have one feature here, only one feature, single feature of x1, right? Because we have not said anything, because we said only x1, x2, x3, x4, which means x1, how many columns of x1 will be the x1 is just one vector. How? But so x is one feature, but there are four samples, right? This is clear, right, guys? X1 is one sample, x2 is another sample, x3 is another sample, x4 is, so there are four samples. We pass it via our hidden layer, output of hidden layer 2, right? Hidden layer 3. I'm just setting up the context. Hidden layer 4, right? Output of hidden layer is, so when you, so this operation will give you logits, and if you, this operation gives you logits, okay? Logits is the value, and when you pass logits to softmax, gives you the probability as class, right? And from the probability, we actually transform into something called as a label, right? That is where threshold is used. Remember that, okay? So this is the network. Are we clear, guys? Are we able to recollect? Now, if you remember, after all these things, we have this weird function, okay? So we were able to actually come to this juncture of saying that my y pred, which is my predicted value, is a function of this softmax of this, so on and so forth, right? And we have also formulated, we at that time, at that day, on that particular time, we said that we need 12 weights at the my hidden layer, h1, 9 in my h2, and 9 in my h3, and so on and so forth, right? At that time, we also said that we said that don't forget we have some bias. So in total that day we figured it out, there are 36 weights and 4 biases, okay? This was the time of that day, okay? We will reevaluate some of the things here. But there are some weights and biases, okay? Let's look at them. However, so are we there with us till now? So my cost function looks something like this, and if I actually look at from a parametric point of view, I was able to find out that not random. Where is random? This is 4, right? Number of trees are 3, right? 1, 2, 3. So this is a very specific network that we trained. So this network is 3, right? 1, 2, 3. This is 1, 2, and 3. We have taken a very specific network, right? And we are trying to understand what is the forward pass and backward pass of that particular network. This is what we started with. Remember on the first day or second day? Nothing has changed from there. And we are continuing to explain ourselves against this network. And that is what we will do now. Okay? So now what we see is that we are able to build a function of function of function. Remember we said that, okay, this is rather complicated to understand. However, this is a final function of this neural network looks like. We also said that in a linear regression, we noted down somewhere, right? So this was in retrospective. So we had 4 features. Linear regression, logistic regression will give an equation like this: m1.x1, m2.x2, m3.x3. Sorry, this is not going to give, because these are all features. This is not there at all. These are all my samples, right? So it will not be like this. This is wrong, isn't it? I said I have only one feature. So it's basically m1.x1 plus c. That's it, done. Right? And that is where we said that this particular equation is such a complicated equation. It will give me very curved lines, and this is just give me a straight line. And this may represent me a very complicated function, and it might be able to handle various things about my data. And that's why we also said that this particular function can be represented like this, right? Right? So essentially what we said is that our function form is nothing but there are so many functions. We have an internal small function called as I, and then on before that we have an H, then before that we have an I, G, F. So we have 1, 2, 3, 4, 5 functions, right? And we said that we will actually represent a computational graph like this. This is how TensorFlow or PyTorch or any computational system will look like this. Are we able to? So this is my ground. Are we able to understand that? Do we recollect? Is there any confusion on this before we move to backward propagation? Because this is very important for us to understand. If you have any questions, let me know right now, please. This is the time for you to ask the question for this particular function. So this whole neural network is defined, the cost function of this neural network is defined like this. Okay, it has a function 6 up till now we have seen that 6 of functions, right? That's all it is. Perfect. We also said that somehow, now that this is the forward pass gives me this function. Now we've also looked at that loss is nothing, everything we cannot change anything. This x is something that we can never change because it's coming from data set. So loss is nothing but the only way I can reduce loss is by tweaking these W's and V's. That's all it is, because these are the ones that I'm choosing and it is my prerogative that I can change them. Now how do we change them? We said that okay, there is this beautiful algorithm called as backward propagation which can compute my gradients, right? Gradients is nothing but how much should I change. So I have to compute this dl by dw. dw means I have to compute my dl by dw as well as my dl by bias. And I have to apply this formula to get my new weights. What is my new weight formula? New weight is nothing but my old weight minus some learning rate. This learning rate is by now you are very aware of what is this learning rate. It is the hyperparameter that you ask, right? And there are some other hyperparameters, but we are ignoring for now, right? Momentum, beta 1, beta 2, based on what optimizer you use. I'm just ignoring them. They're just some numbers, right? So what this is the basic equation, right? So change my W old by that much amount. This is my gradient I have to find out, right? So backward propagation gives me this value, and this is what gets applied when you do that is what goes to my optimizer, and optimizer applies it universally, right? Correct? Do you remember this card? This is clear, right? All of you are with me now? If it's getting heavy, let me know, guys. This is something that we did that day. Okay? Second day, third day, I don't remember exactly. I think it's on third day. So this is the general equation of updating any weights in any neural network anywhere, right? It might get complicated based on which network you choose, but ultimately this is something similar will be applied. Maybe there are other terms, but this is what it is. Simple. Are we there? Okay. So now we also said that, so to compute this dl by derivative of loss, so that is what, so can you discuss gradient descent or ascent and fit in this equation? So that is what we will do, right? So we will do backward propagation. So you want to do gradient descent. So now this was my loss function, remember? This is my loss function, remember? Right? So this was my W old. This is my W old, right? My objective is to reach here, right? My objective is to reach here. As of now, I only know some sort of local minima. So this is my W old. The only way to reach is to go down. I can't go up because up means high value. So how will I go down? I have to come. This is my W old, right? W old, correct? And this will be my W new. This will be. I don't know what is this. Now to reach there, I need to go so much. I have to update all my W olds in such a way that I can actually reach there. So now to compute this, this will be my dW, this will be my dl by, sorry, this will be my dl by the dW whatever, right? Sorry, let me just actually, this will be my dW, no, yeah, let's be very clear, dW old, right? So if I know this value, then only I can apply on W old, and then only I will get reach here, right? If I know this value, that how much I have to update, then only I'll be computing this formula, remember, and then I will reach my W new. So that is my gradient descent does, right? So descending now. So now I have a gradient. I don't have a gradient yet, right? So now we'll see. So now we'll say that, okay, to compute my dl by dw, the first rule of a differential equation is that if you are going to compute a partial derivative of two terms, in this case I have two terms, I am trying to compute how much I have to change W old to change L. In other words, what is my change, rate of change of my L, in this case loss, to my W old. That's all. If I just compute this term, everything else is just static value, nothing else, right? Now it's not easy to compute this value. The whole life of our backward propagation is to compute this value. This value is not so easy. Why is this value not so easy? Because if you have to compute a value like this, you need to look at all the places that W old is affecting L. And from the chain rule, we find something like this, that it is affecting that W old is some big derivative, okay? Right? Is that clear? So now this is based on the chain rule. For now, let's understand local minima. But default gradient descent only gives you this, right? Then momentum will put you on top of here. The gradient calculation will always be same, isn't it? Momentum, other terms will actually push you down the hill, right? Adam will give you, what will it do? It will have variable learning rates. But the default, the core gradient calculation remains same, isn't it? At its core, so understood, right? Momentum just helps him in, what does momentum does? To jump over this hill and go to a new and find a new local minima. That's all, right? The actual core gradient computation is something that we are discussing right now. Okay, na? Are we able to understand now? So let's understand that how do we even compute this dl by dw old. It's very critical for us to understand this part, right? So now one thing is very sure, right? The computation of, so we know that that's a different question. How will it finalize this? This is only going to be global minima. It doesn't, never. In first order optimization, it never knows that it is global minima, approximates, right? There is no way you can find out there is global minima. There can be many values and corners. You would just reach to one. You can allow the network to train for eternity, but you will not do that, right? You will at some point stop it. But if you allow it for eternity, if you have really like convoluted loss functions, it will continue to train. But at some point you have to stop it. You have no access to that global minimum because you don't know that the valley is so up and down. You do a stopping based on your acceptable limit of choice. Okay, let us do one thing, guys. Let us focus on the gradient computation. Okay, this is a very fundamental reason and this will be applied everywhere. If you understand how the gradient computation works, you can apply this idea everywhere. So we have understood that we need to apply a weight and we have to compute this value of dl by dw old. And this is nothing but our numerical value. It's going to be a normal scalar value, right? Some sort of scalar value, right? And we will see. So what has been said here is that we also know one thing, that all these weights on various weights, old weights, new weights are all what? So if you actually look at this, right, this will be my all or everything is matrix, right? Do you agree that everything is a matrix? We have a matrix of W. We will have a matrix of W new. This is per neuron per layer. We will also have a matrix of, we have a matrix of W old. This has been achieved once for every time you do a forward pass. One output of forward pass is also W old, right? You have got a W's. Now you have to reduce the W. Similarly, you will also have a matrix of dl by dw. So this is nothing but my gradient or negative gradient of my cost. So if you actually see, right, how many W holes we have, we said that in that day. Now just now we said, right, we have 40 Ws. Sorry. We have total 40 Ws, right? So basically, this matrix is nothing but a collection of 40 Ws. Each of them, like if I actually name each of the Ws, right? If I name each of those, this is a nothing but a matrix of W old 1, W old 2, W old 3, like dot, 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 W40. Are we able to understand this? The complications of this, right? Each and every weight has to be reduced by that much amount, right? It's not just one weight, right? We said that this three hidden layer plus one output layer has 40 weights and biases. We will see that it is actually not 40, it's 7 more, but we will actually separate weight and bias, okay, in shortly. But overall, let's say it's 40, and we have to change each of those values, right? We have to set each of those values. Are we able to understand that? Just about, are we clear about that? We have to change each of those 40 values, not just one value, because we are not dealing with one value. Guys, anyone, before I move, okay, before I move, are we able to comprehend this part, that we have to change each of the W value, and there are 40 of those. And if you put it in a matrix order, it will be looking something like this. I will only move if I get some yes. Or else there is no point of moving. Guys, ask me questions if you want to, if you really are, if you want to go through this, okay, one more time. But I'll give you guys couple of minutes to actually digest this, okay. That this value is also a matrix, that just that this value is actually a matrix, that our output layer, our layer has 40 weights, and when we do backward propagation, my loss depends on each of those 40 weights, not just some random weight, right? We have started with one weight, but there are actually 40 weights. It is difficult to explain something, but that's what it is. There are 40 weights and biases, right? So, and this matrix represents exactly that, okay, right? So which means I have to do chain rule for each of them, okay. So now that we have understood, I've got a yup. So now let us do one thing. Let us revisit. Let us do one thing. Let us do some more. So let us see how the backward passes work, and you will see that it is not actually very tough. It is just, you know, it's such a beautiful thing that once you realize this, that what happens. So we said that. What did we say? Let me just switch on the chat once. Okay, we said that we have to compute this dw by d dot. But let's be very clear, okay? We have been totally ignoring biases like anything. We will no more ignore bias, and we will be perfectly clear that how many weights and how many biases come. It will be perfectly clear that how many weights and how many biases are there in this layer. I have to do. I have to run a backward propagation algorithm, right? So now what I did is that, because I did what I can do, is like I simply wrote a simple normal TensorFlow layer for exactly that thing, and when I ran it, I found out there are 47 parameters. Okay, it's not 40, there are actually 47 weights in that particular model of ours. Okay, which has three layers, like three dense layers, isn't it, and one output layer. Perfect, with two classes, right? That's all it is. And if you actually segregate each of this layer, input layer has no weight matrix and bias, right? Do you guys agree to this? Input has 4 samples. We don't have any input by weight or bias, right? Do you want me to go to that image one more time? Are we clear? There's nothing coming here, right? This doesn't exist, right? Clear? Yeah. So now my H1 layer has 3 neurons. So my weight matrix will look like what? These guys use. You guys have already told me that there are 12 weight matrix, right? 12 weights. But the 12 weight will not be like a long matrix, it's going to be 4 by 3 matrix, right? Which means I have 4 rows and 3 columns, right? Which means 4 samples, 3 neurons connection, right? For each of those line, so for each of those line I have a matrix index. So I have W011, W012, W013. So this indicates my neurons H1 layer first neurons first mate, H1 layer first neuron second weight, like that. Okay, all the connections, right? Are we able to understand that? So I've deconstructed each of the weights and each of the biases. And so my bias will be 1 into 3, right? Per neuron per layer, right? So this is my constructive thing, and if I actually add it each of them, okay, 12 plus 3, 12 plus 6 plus 6 plus, if you add all of them, you have 47, which matches with my code, right? And so essentially there are 36 weights and there are 11 biases. Now if I have to backward propagate, I need to update each of these things in a way so that my loss reduces. My loss curve, let's go to the loss curve. This value is comprises of 36 weights and 11 biases. So if I have to reach here, I have to update 36 weights, 11 biases, and each at the right position, right? Because each of the weights have proper link, right? They point to a specific neuron, input and output, right? They are not random. We need to know them where we have to update, right? The purpose of writing like this is the clear cut software engineering trick. Because why? Because I need to know which index of the weight I am updating, and for which layer. I cannot simply randomly update some weight which is not supposed to be updated at all, right? So I need to know the mechanism, the code has to know that you are updating this particular weight by 0.3, this particular weight by 0.2, this particular weight by 0.5, and so on and so forth. Okay? Are we able to understand it? Are you able to understand this? If you want a moment, take a moment, but realize that this is my weight and weight matrix and bias matrix of this. This is the true. There are no more discrepancy. I have been telling you 10, 15, 12, 40, all wrong. Ultimately it has 47, okay? And out of which there are 36 weights, and each of the weight matrix, each of the hidden layers looks like exactly like this, and I have given each of them a name. So now I can call each one of them and ask them, blah, boss, you are this value, please update you to this value. So I have given them an index, I know their positions, I know which layer they belong, I know which neuron they are connected to, right? Which two neuron they are connected to, which two layers, all those things I have known. So this is my master data sheet. If I don't know this, there is no way I can update a specific value. You guys agree to that, right? So this is one, when you do forward pass also builds this dictionary. And this dictionary is, how do we build this dictionary? Via that computation graph. Okay. If you do the computation, the computation graph is a little bit mathematical, but the thing is that it gives you this information as well, like which weight is connected to which weight and everything else. Okay, so it becomes easier for you to manage. There is no separate list that you're doing it. Okay. Okay. Are we able to understand? No, Suchita, are you there in this back propagation? Are you doing the back propagation right now? We are doing back propagation, right? So can we solve this now? And once we solve these things, we'll come back to this, right? No, bias, no, that's not correct. Bias B11 is not same as these things. Bias is a different thing. What is the general equation of, so what is the mate matrix? So hidden layers, remember what was the hidden layers? H1 will be what? A good question. What is H1? H1 is nothing but ReLU of weight 0 into my X plus my B0, right? So where weight 0 is my this matrix, B0 is my this matrix, X is my input. Are you able to understand, Uttam? Now, are you able to understand why you need to separate my weight matrix and bias matrix? Huh? So what is my, so we saw that, right? Okay, let's go back, no problem. So let's go back to, so what is my, this is my hidden layer, right? This is value of weight of X, right? So this is my W0, this is my B0, and this is my input. This W0 is of 4 by 3 matrix. This bias is my 1 into 3 matrix. And X is my 1 into 4 into 1 matrix, right? This is the equation. So hence W0 is different than B0. Okay? I generally don't do this because it's little intense. Okay? So this is not, this is, so these two are different. W0 and B0 are different. Okay? Shall I proceed? Are you able to understand this now? So this is for each layers, neurons, each layers, weights and biases. Okay? Now, if this is if this is if this is my position of my each weights and biases, if you don't do backward propagation in coding at all, because who handles the backward propagation, you don't have to do anything, right? So number of neurons is based on whom? Yeah, of course us, right? We've gone through the Keras tuner, so it's the hyperparameter tuner will do it, right? So if this is my, if this is my position of my weight matrix and bias matrix, I am going to update my, and there is a reason why I'll update, okay? I'm going to update my graph, okay? What I will say is that I'm going to update my graph into something like this. This is my full graph, okay? What this graph says is that, okay, I'm just going to explain to you, this is exactly same as what I had my earlier graph. Only thing is that I have ensured that things are separate in some way. So what I'm saying is that earlier, my first layer, this is my hidden layer. This actually, this is my first, sorry, this is my input. So this is my H1, this is my H2, this is my H3, and this is my output, okay? So what happens is that first my bias come and my weight come, I do some aggregation function. What is my aggregation operation? Do we remember what is my aggregation operation? It is weight into X. So these are three terms which are coming to my this function. Weight into X plus P0, right? Right? So are we able to understand this, guys? So my I aggregation function is nothing but it takes three objects, right? Let me just actually do one more time. Three values. One is W0, X and B0. I pass into my I aggregation function. It does the aggregate, that summation operation, the aggregation operation. Then it passes to my activation. So I is nothing but activation. Okay. It gives me the value. So now activation of I is becomes my input. And then for this layer, I have my own B1, own W1, right? Remember? Goes and does an aggregation. Same thing happens, continues to happen till the last. What I have done is that I have formulated that there are there are 10 layers go from down, okay, and each of them have their functions, right? So each of them have their functions. This is important for us to understand. There is a reason why I'm actually I'm almost there. So why this is very important for us to understand is because without this, it is almost impossible for me to teach backward propagation intuitively. If I open maths, all of us will run away. Some of us will run away, not all of us. Okay? Because it's all differential calculus, right? Nothing else is there. Now the thing is that, please understand one thing. What are we doing here? We are, should we use the secant while building? Which one is better? No. So are we able to? So this is my aggregation and this is my activation. This is my aggregation. This is my activation. This is my aggregation. This is my activation of the same function. So right. So my aggregation takes three values. my activation doesn't take only one value. Now intuitively, see now if I actually take, so let's do one thing. So now that you have understood this, right? I'm assuming that you have understood it. It will take some time. It is okay. Okay, I will share this note again and you can take your time to look at it. So if you look at the only last two layer, and let's focus on this because our objective is to learn L. You have to find out that we are only interested in B and W's, nothing else, remember, right? So for every layer, I have to be interested in my B's and W's, right? Sorry. At first aggregation, no. So this, what is the value of our aggregation? This is, let's look at what is I aggregation. Okay, this is I aggregation. Can you see my x into W0 plus B0? This is what we said, right? I aggregation's equation is nothing but x. Your input is x into W0, which is my weight matrix. And what is my W0? This is my W0. This matrix is my W0. I have a name for each of the weights, okay? So it's not going anywhere. So I will multiply that weight matrix into my input and then add it with my bias to get my output of I aggregation. Clear? Is that clear, Uttam? And I will get a value out of it, which I will pass it by my ReLU. This is my ReLU, right? So I will pass by, it is input to the next aggregation. So what is my input to the next aggregation? Output of my activation is my input to the next aggregation, right? Now you are asking the right question. You are thinking now. So what is my input to the next aggregation? Output of my final activation of that layer, right? Output of my activation will be my input to my aggregation. That is what we do, right? Do you want to look at this? So let's come here. So this is my I aggregation. This part is my I aggregation and this is my I. Okay? This is my I aggregation and this part is my I. Sorry, some other. This is my ij or whatever the next function is. So whenever I have added dash aggregation, this operation is my aggregation operation. Okay? And then I wrap it via my ReLU to pass into my next layer. Is that correct? Praveen, is that okay? And I have just done the same thing but in a different manner, so that I just wanted to I wanted to ensure that we, now it becomes easier. So now if you actually look at this, right? If you actually look at this, okay? If I actually just look at the last two layers and this image and forget about everything else, sorry, don't forget about everything else. If I have to change my loss, we said that we have to change the loss. Yeah, of course. For every new layer, I have my bias and weight, right? So let's go back again. For my hidden layer H2, W1, B1, correct? For hidden layer H3, W2, B2. You cannot say that why I am not started with a W1, B1 itself. I have a zero index problem. I always start with 0th index. Too much programming. Okay? That's all it is. I could have easily started with W1 so that it's H1. Okay? That's all it is. But yes, I think I should do that so that it's just readability is good. So every layer has its own weight matrix and a bias matrix, and every layer has two operation: aggregation operation per neuron, activation operation per neuron overall, right? So this is what I do, and this is all the various operation I do. This you know, by the way. Huh? This is nothing but multiplication, addition, and nothing else. ReLU, you know it very well. If the output of my aggregation is more than 1, if more than 0, then that value or else 0. It's a very simple max operation, nothing else. ReLU is that simple, as simple as that. Now let's look at the last two layer, only last two layer, okay? And we will close it out. Don't worry. It's very simple now. If you look at the last two layer, L, we said that we can only change L. Everything else is static, X space, whatever is coming. L. So for this layer, this is my H1 layer, right? This will be my H1 layer, F layer, right? Sorry, this will be my F layer, right? So now from L, So from L, what we'll do is like, right, you have to change your B3 and W3, right? So how will you change it? And then so let's look at this. So if we actually just look at the last two layers, it becomes very simple now. That if we just look at the last two layers, all you have to do is that you have to find derivative of three things, right? Look at the last two layers. You have to find a derivative of L base for B3, right? L for W3 and L for G. So that is exactly I have separated out. So first derivative is derivative of L with respect to weight W3, right? Derivative of L with respect to the B3, right? And derivative of L with respect to previous activation function G. So if we compute these three derivatives and just add them up, we are done. Actually, we don't have to add them up. We just have to compute derivative of all these three things and keep the value ready. Now, how do we compute derivative of W3 to an L? So just take any one particular weight of that particular, I have taken one specific weight, and this is the function given by chain rule, right? We know it, right? And if you see that, if you see the equation of F aggregate, let me just increase, the thing a little bit more, is that if you see df of aggregate divided by dw311, it will come to the value of the whatever the previous output has come, because this is the rule of derivation. If you have done basic differentiation in 11 12 or 10 11 12, I don't remember when, right? If you actually do a d of, if this is your equation, right, this is constant, this goes away, and I'm doing df aggregation by d3, so this will cancel out. So only thing remaining is g. So g is nothing but the output of the previous layer. So this is nothing but a scalar value or a matrix value of output of the previous layer, this value. Multiply that with df by dagg, right? This is nothing but Rayleigh's differentiation. What is the Rayleigh's differentiation or derivative value? It is 1 if the x is more than 0, and if it is 0 if x is less than 0. Okay. Use the rule of differential calculus. You will find Rayleigh's differential like exactly like that. Okay. And what will be my dl by dg? So now for that you need to find out a differential equation of categorical cross entropy. Okay. There is a link that I have given. You can actually look at this if you are interested in math. That how do I do differential calculus equation of minus y log of y? That's all it is, right? This is basically you have to just do differentiate this one, nothing else. So basically you equate these three things separately. Not you, back propagation does it for us, right? It will equate these things separately. You will come up with a weight matrix, nothing else. Literally, this will come up with a weight matrix. Now the thing is that the only glitch is that this loss that we computed is only for one value, because for every example we actually get a loss, right? So what we do, we recompute this for each of the examples. In your batch, you have a batch, you always give mini batch 50, mini batch 20, mini batch 128. So you have to recompute for all of them and do an average, right? Not recompute, basically add them up and do an average, right? So this is only for that particular layer, guys, a specific W311. So there's an arrow will indicate me which one is the W311. So this is my last layer. I started from back, right? So this specific value is what I'm computing, nothing else, right? So once I compute this, I have my actual gradient for that particular weight matrix. I am done basically. So now I will compute for each of that particular weight in that particular layer like this and keep it ready. Optimizer can simply take this thing, apply, and I will have that last layers new W3 new. Okay, it's as simple as that. Okay. Now we'll move to the next value, which is nothing but derivative of L with respect to my weight bias. I will do the same operation and I will find out my new B3 matrix, whatever is my new B3 matrix. Same operation. And if you see the equations are very simple. F aggregate by D B3 will nothing but be 1. It will always be 1. Okay. Differentiation of this will always be 1. whatever you do. Okay, these two are already computed. We have already covered it, right? As when we are computing the dw by for the weight part. So just replace the value and compute this. And again, this has been for one loss. Compute over all loss. Do an average. Then that is not it. You have to now sum it for all. So you have to do it for each and every weight matrix for that particular. How many weights are there in my last layer? Let's look at it. We have actually two weights, so we have to compute this for this and this two weights. And I keep my updated things ready. Okay, these two are done. My final thing, which is a little tricky, is to compute my L against my previous activation function. And if you follow this, okay, if you again follow the same thing, right, it's already computed. These two are already computed. If you actually follow this, this value equates to W3, literally the weights that the old weights, nothing else. Okay, this is nothing, this equation literally equates to old weight, nothing else. Replace it, okay, sum it across, you have to do double summation, okay, and then you are ready with these three values. Once you are ready with this three value, what happens? You are ready. So now optimizer is backward propagation has done its job. It has got the full gradient of each weight of those 36 weights and 11 biases in different form matrix, and it knows the exact position it has to update. You give this to your what is that? What is its name? Optimizer. Optimizer will does do dot apply weights, basically dot apply gradients, and it will update at a full go. Okay, this is what the whole backward propagation does. We don't do anything. We basically literally we just control the thing, right? We just control it by mentioning LR and HR, but we don't do any. We don't have to do anything. And it's a good thing that you should know. If you want to go deep, really deep, go to Chris Ola's article on calculation on computation graphs, backward propagation. The reason is that you need to understand the computation graph, or else it becomes really mind bending to actually understand it. Okay, it's from a graphical standpoint. This is a good presentation of if someone wants to go beyond what I've just discussed, right? But this is what a back propagation does. We don't have to write in a single line of code. We simply have to give a forward propagation, right? And of course, every network with its own brings your complexity. For an LSTM network, how many networks do we have? One LSTM cell. Do we remember? Do we remember how many cells we have in LSTM? Sorry, how many networks do we have in one LSTM cell? Anyone? No one? Everybody forgot LSTM? So there are no. There are actually four networks, right? Remember, there are four networks, not one, three. And yeah, so there are eight layers, right? So it is just so this weight matrix and this computation basically remains same. Only thing is that you have this number of matrices are extremely large, right? That's all it is. But the equations are almost similar. It's just that computation happens at a scale which is really big, right? If you're talking about 500 trillion weights, 500 billion weights, so think about it, applying the gradient, calculating gradient for all of them, it's a gigantic effort, right? So the basic working is this, but backward propagation is such an efficient algorithm. It works via mini batch, and it does a lot of mathematical computations to make this thing effective. We don't have to do anything. We simply have to provide a net layer which accepts a gradient and applies it. That's all it is, and ensure that it uses a function which is differentiable, and that's about it. Little too involved, but if you are doing anything serious with neural network, this is something that is good to know. It will be easier for you to understand. Okay, I will share this one. Don't worry, guys. I will share this one, right? I don't expect you guys to have any question, but if you have, let me know. But generally, this is a little heavier, but it's okay. Heavy is good. Heavy is not bad. Okay. Am I taking any Tableau batch? No, I mostly stay in neural network, computer vision, machine learning landscape. Okay. We can discuss that. Yeah, definitely. So this is model serving ML ops. Any batch, that is something that you can ask this guys, no, learning success manager. You can ask them. Okay. I don't have all visibility, but right now no. But you just ask them. Okay. It's better to ask them. If you want, if you want to see model serving. Sorry. So what is the interview question? Oh. How will the interview questions on this topic? So the thing is this: any interview questions, right? Anywhere in the interview, they will give you a feeler. They will, based on your response, they will dig deep. If you say something intelligent, and if you mean that, when I say intelligent, not in a bad way, I'm saying that suppose you say that you need to compute gradients of each of these things, then the next set of questions will come if the interviewer, I'm assuming, on the other side. But yes, I think on the projects, not necessarily. You will have lots of concepts. If you're talking, if you are getting, if you are getting hired for an ML engineer, definitely there are projects on the active. Yeah, I mean there will be, but I would assume a new use case will be given and concepts definitely. If you are getting hired for a machine learning engineer, if you are applying for a post for a machine learning engineer, there will be 3 or 4 rounds. One of the rounds will be concepts, another round will be coding, 100%, and both are equally important. And the third round or one of the rounds will be a use case, right? They will give you a brand new use case, and most probably they will ask you to code. I'm talking about if machine learning engineer, like hands-on kind of a role, okay? Even if you go till the time point of a, till director of engineering of AI as well, right? There will be some amount of code. At least I have seen, okay? Don't want to scare everyone, but I have seen at least in startups and all. Because big companies, I'm not sure. I think there will also be some one round of technical understanding. But one thing is, this thing is that, you have to understand is, this is a classic question, right? Sigmoid versus what will be the very question I keep on missing these questions. I'm not joking, okay? Is that multi-level versus multi-class, right? Very classic interview style question. Okay. When should I use ROC versus AUC? You asked, right? That's a very classic interview style question. And something like that. Okay. How many weights and biases will be there if I give you a layer, right? Classic question. The acceptance criteria will be less if you are like me, and if I say 40, and then there will be not a much of a time to change that to 47. What you can show is the process of how to calculate it. That is more, or you can verbalize that. That gets the job done basically most of the time. If you have a realistic guy who's actually taking it. Okay. But it's gonna be basically three aspects. Okay. Um, so that's one thing that you have to understand. Can we discuss deployment and some end-to-end projects? Can you just give? We can do that. We can. Let's do one thing. Let's take a break. I know this has been heavy, and let's rest of the half hour, 1.5 hours. We can ask all questions, and we can go all over it. Okay, and see where we land. Okay. Does that work for you guys? Shall we take a 15 minutes break? Let's do that. Thank you very much. Okay, folks. We are back. Let's open up for questioning, shall we? What is that you want to go through next? Can you, Suchita, right? Can you, is there a way you can actually share the code? I'm audible, yeah. Or just at least put, or put the, can you just put the code here in the worst case, just put the code, at least the model structure and the compile part, model.compile part in your, in here. Yeah, I can. Yeah, I think that is also possible, no? Right, right. So let me just try to see whether I don't know whether you can. I can check whether share screen. I don't think. I don't know whether you can do share screen or not. Okay, and the model part, model. No, let me just. Let's do one thing. No? Let's. So this is what you did, and oh, so let me just. You guys can see my screen? No, you can't. Let me just share that. VS Code. You're able to see my screen? I've shared my IDE. I just wanted to check whether, yeah. So sequential convolution, okay. So this is fine. TF dot flatten, huh? Okay. You have added flatten, fine. Module, huh? Okay. No, but okay, can you send the shape of your train set and this? What is your train set? Can you also print like this train set dot shape? And where is your train set has there are where is your X trend Y trend and X test Y test? Train set is what? Train set is a tuple. Just give us a train set dot shape and train test dot shape. Generally, what happens is that your train test it should be train X comma train. I'm not saying you can't do this. That but it's 5 filter input shape is so your input shape is 100 100 3. Okay. And the error that you are getting, no, so train set is what is train set? I don't know what is train set. So you need to give an X train and Y train, right, to model fit, and your validation should be an X test and Y test. And the set, if you are giving a train set, then that has to be a tuple of X, this thing, right? So you have to give an X and Y, right? So your error that you are getting right now, I'm just trying to copy paste it. If I use what? Yeah, so your shape are incompatible. Shapes are none. No, so TF dot flatten. This is so you have to give model dot add, right, in the flatten. So you have not done the flatten. In the flatten, you have to give model dot add, right? Okay, yeah, image data generator. Perfect. Can you also give the image data generator? Perfect. Yeah. Can you add model dot add flatten here in this particular line? Add a flatten layer. That's what you're trying to say. Use, right? One second. Let me just copy paste and put it in somewhere else. Okay. Let us go to our assisted tone safe. Okay. So we have a lot of, so we have convolution neural net assisted. This is right, and so this is where we have added a lot of things, right? So this is how you can add a flatten. You can see this. So it's in your code you have flatten. So so you want to add flatten or not? So then remove that code. Okay. So basically, yeah. So what I'm saying is that in your code you have flatten. So what I'll do is like I will put like this. I think there should convolution. This code is not allowing in my PC. What is convolution 2D? It should be con 2D, right? It should be con 2D, right, class, right? Are you giving us the exact code? So convolution. Share as the code. Actually, I think I see that there's some sort of discrepancy. Convolution 2D is not the class, right? We have con 2D. So are you using the right code? So you have to use. So I'm just copy pasting what you have put. So basically, so this is convolution 2D Keras. One second, is it an alias? I have Keras. Is it an alias? Convolution layer, convolution 2D. This one. Okay. So this is which part of this is? One second, just one second. Oh, right. So what you have done is that you are using Keras 2 1.2. Just so don't use Keras 1. Just check your TensorFlow version and use Keras.10. So in TensorFlow 2.0, Keras is inside. You don't have to separately install. Okay. You have to ensure that you are on TensorFlow 2.0. Okay. Versions should be very important for you. You have to ensure that you are in TensorFlow 2.0, please. Okay. And inside TensorFlow 2.0, you have Keras. Keras version is also 2.0. Okay. So what you do is like in your assisted practice, check assisted 1.ipynb. Okay. This you already have. So this one is actually, let me go back. So this one, just follow this code. Okay. If you are able to run this code, I think this is on this you use, yeah. So you can use 3.5. So not convolution neural network. What am I seeing? Sorry, this is self-learning. So go to your convolution lesson 6, okay, and 6.3. In 6.3, download the sample and use that as your base. Okay, if you use that as your base, you should be able to, and use the Anaconda distribution. If you have you're running in your local, right? So use the Anaconda distribution of Python. If you are running from your local, okay. See, you will, if you have multiple Pythons, it will show you something like this. I'm just showing you a different ID. This is visual code, okay. But essentially, your Python should be under Anaconda. Then all these things problems should not come. And use this, okay. 6.3 is assisted code. I totally forgot that this is TensorFlow Keras 1.2.2. That is old version. Do not use that, first of all. Second of all, follow 6.3. Download this and build on top of it. Okay. And if you actually see 6.3, okay, this is simple, right? Contour, and dense 10 instead of dense 10, you used to 2. And since we have already used image generator, which is a good thing that you did. Okay, though we haven't gone through image generator, but that is awesome thing that you did. Everything should be fairly simple. That's it, right? If you use the image generator, use this as your base and change the things that you want to change. That's all it is. Yeah, this will be a good thing. That's very clear. Okay. Okay. So, what are we supposed to discuss? Any questions, folks? It's all on you. Okay, if you can actually no. There was some questions here, right? Any question that you want to ask? Now is the time. You wanted to know what is ML ops, right? Someone was asking about it, right, John? Uh, can we discuss deployment and some end-to-end projects? Okay. Praveen. Praveen, can you explain a little bit more your query? I may be able to help you if you can actually ask this question one more time. Yes, that's correct. Yeah. Convolution 2D, yeah, that convolution 2D, I totally forgot. It used to be no. No, so you had a question, right, Praveen? Can you please ask the question? You asked something, right? Can you please just ask one more time for us? It will be better if you can ask one more time, please. Yeah, so deployment of, can you elaborate what you mean by deployment of what? Models, application? Deployment would mean a lot of things, right? Okay. So you for deployment of models, there are lots and lots of options, right? So you can use sensor board. ML ops is a huge topic on its own, right? ML ops has a lot of you know parts to it, right? And if you in fact go to TensorFlow's documentation on ML ops, okay. In fact, ML ops, Google, there's a very nice, yeah, documentation on this, right? So this is a very nice documentation on a continuous delivery and automation of pipelines in machine learning. Let me share the link, okay? And cloud architecture center has a lot of good um, um, documentation, right? So one part of it is serving infrastructure, but there are a lot of things that happens, right? So if you have a ML, so you have the code, this is the model, right? There's a continuous, your new data is coming. You may be based on something, you have to regenerate the model and do an A/B testing kind of thing to find out whether you have to regenerate the model or not, right? Or new data engineering, serving infrastructure. Is your inference API going down, okay, over the period of time? What happens is that as and when more and more data comes, right, your inference might actually go down. So if it goes down below certain threshold, you would have to return and put it back, right? Model code versioning also. So look at this blog article. Okay, they take a very established approach of DevOps. If people who are from software engineering, they have known this, right? Continuous integration and continuous delivery. They have taken MLOps is nothing but an extension, right? I from an ideation standpoint, but however it is, you can't simply just put a newly done machine learning model into production as it is, right? So that is one thing, that there's a full-fledged process around it. Okay, and if you have a very big established pipeline, you will have some sort of ML ops. And one thing is for sure, that you will have some trained model. Okay, there will be checks and balances to even put it to model registry. You can use model registries you for TensorBoard or weights and biases. I showed you, right? Weights and biases. Have you seen that, right? Weights and biases. Weights and sorry. So WNB, right? Weights and biases. Yeah. So this is a very popular WNB site which allows you to track your model performance and do hyperparameter tuning, do A/B testing. Okay. Do some sort of a lot of things there. Experiments, reports, artifacts, visualizations you can do at a huge scale. Okay. And this is a very simple. Like if you actually do TensorFlow, right? See, all you have to do is like just add this simple line, and it will start pushing from your direct model training to weights and biases, and weights and biases then become your single gateway for all these things. Okay. TensorBoard tensor service also is very nice. Okay. I mean, Google has just taken this to a different level altogether. But a lot of times, what happens? They have restricted, and the velocity at these small startups work is generally faster than these big companies, isn't it? And they are very specialized. So you can look at this weights and biases. It's pretty good. It's a very small line of code that you have to add like this, and it will start putting the data directly to your logs in your WNB account directly, and you can straight away visualize like this. Okay. So that is a very there's a see, you can try a live notebook as well here. So this just look at it. Okay, a lot of people are moving to this. There's also other alternative, right? AWS SageMaker and Azure as a machine learning infrastructure. There's other places as well. But this is a very involved place, ML ops itself. Is there any other specific question that you want to ask, Praveen? End-to-end projects, so can you just explain to me what do you mean by end-to-end projects? What do you mean by can you explain a little bit more about the question? So what are these? Yeah, so what are end-to-end projects? I mean, given by the sparsity of the information that you have asked me, I'm not able to. I don't know whether I'll be able to answer it to its own. Is that examples of an end-to-end project in data science? Yes, like hundreds, right? I mean, Google Maps itself is an end-to-end project, right? Loan system, right? All these projects that you are doing is an end-to-end project, right? This assessment problem, house loan data analysis is an end-to-end project, right? The only part that you are right now working is only the machine learning part. There will be part before this which has, so which will have a data ingestion system, right? A typical loan house will have a multiple data ingestion system, sorry, multiple places where the loans might come, right? A bank will have a backend loan system, right? That is probably been stored somewhere. So you will have a data ingestion system which comes and becomes. There will be a data engineering pipeline. How come we get the code implemented in the? So this is exactly the same with the way you're adding. So that, but how come we get the code implemented in the? So code you will implement exactly like this. Only thing is that you might not use Jupyter Notebook. You will have to use a .py notebook, right? uh, a Python program, because Jupyter Notebook has its own limit. I mean, it's not that people are not running it, but running it in a Jupyter notebook might be a little difficult at a very large scale. Not impossible. A lot of people are doing it. I generally prefer to use a normal application, a Python application, and using .py files. Okay, but the code will not look very drastically different than what you have been you are doing. All these processes that we have gone through is all valid processes. You know, all these things we do, EDA, data preprocessing, each of them will have its own format. Yeah, exactly. It's going to be easier to make an API if it's in PY format. Perfect. Yeah. All these things are important. What you're learning is, building blocks, or all these building blocks, are the right thing and they are representative of the real world scenario. They are not some fictitious thing that people don't use. They use it. The reason that you have been taught Jupyter Notebook, because it is easy to explain and easy to execute in a environment like this. But if you already have a background in software engineering, you would know that you would need to actually sometimes create a executable, isn't it? An executable, a version control system, and so on and so forth. The py file, just like if anyone in the Java or JavaScript, or they would know that this is not exactly the py file will be the source file, and you would use create classes. If you remember, one of the first neural networks that we did was class, right? So you can create your own class, wrap it around, use Keras inside it, and so in that case you will build functionality of classes, right? And you will actually, so if you want, and you will do cross validation, you will have an EDA system. All of this you will have to generate logs. Logs has to be outputted in some logged stash kind of a system. Model will generate logs which will go to your weights and biases. They will have to get analyzed and searched. So all the software engineering things has to be there everywhere. Without this, it will be very difficult for you to manage a really large scale production ready system, isn't it? But if you actually see, these are actually practical house loan and data analysis, ending card loan data analysis. It's actually a live problem, right? People use it, right? All the places where you actually apply for house loan, first indicator is nothing but a learning model, a software which tells you whether we are eligible or not, right? It can be overridden. So then you have to override the decision making system. You have to write web app, UI, and all the other things, right? That is non-machine learning part of it. So end to end is that machine learning part is small. You will have a lot of other things also from a software engineering side of things to bring together. From my point of view, if you ask me, from an operational data scientist point of view, a great software engineer generally does really well in this field because of his inherent nature of inquisitiveness. Given a set of API, it is not difficult for a software engineer to find its way out. Okay, and if Keras is the API structure, you will find its own way out, and at right moment you will go deep dig and on things like that. Okay, so I would highly encourage people who want to get serious, at least if your job title is machine learning engineer or something similar, then definitely you have to know software engineering and have to because you will be tasked to build production ready AI systems, intelligent systems, learnable systems, machine learning systems, right? Whatever you can call them. So that's a little bit involved game, is what I'm saying. Okay. So parallelly with this, I strongly suggest that you guys should actually look for SQL. Okay. because you have to also understand how data works. You have to know programming, coding. All those things will help you to ancillary parts of the things. Okay, to make, if you are into making that production ready system, that is what it is. Ability to read a documentation, and if it's needed, that you can also open Keras code base, and you can open Keras code base. Every of the API has a link to Keras, by the way. You have seen that, right? Just open conv layer, you can see that I just seen. You can see this, right? This is source. Click here, you will go to the source code itself. So this is Keras source code, and this documentation is here itself. It's not that very difficult, right? Right? You can see convolution 2D. This is an alias which has been created. Right? And Keras currently is in 2.9.0, as same as you know you should be able to look at the code and then react as per accordingly, right? If you see like this thing, right, the way again, the way you ask this question, right, how can I know what is happening? If you look at this guy's blogs, okay, Andrej Karpati, if you know who this guy is, right, he has a very vibrant blog, and what he does is that he was till last week, he was the Tesla's AI director, right? And he has done some great things. Very young guy, but has done great things. So he deconstructs all these notions, and he most of the things he does it in JavaScript. Not that he does not in production system. So look at this code. Deep neural network 33 years ago in 1989. Jan LeCun did an end-to-end neural network with backpropagation. He reconstructed the same paper in recently and gave his. So you can look at the how people are doing it, right? So this guy, he's implemented some really complicated algorithms in JavaScript. Going back to say, going on a, like as in like enforcing the fact that language, you can implement all these things in any language. These are all just mathematical equations, right? Pluses and minuses. If you understand what you're doing, that's it. So we think that only Python is the so it's not true actually, right? There's a lot of other languages also which are doing it. So whatever language you're comfortable with, you can start. If you're comfortable with Java, I don't know how many people are there in Java. Deep learning is coming as Deepika Padukone. Okay. So deep learning for J. Right? I don't know how many people are in Java, and this is a question that I get a lot. So you can see this deep learning for J. This is now has become the de facto standard in Java. This was not that active, and this community is now very active now. So you can build deep learning model in Java right now. And there's also a language called as Julia, if you know. Right. So all of these things have so Julia packages, right? All of this has no, language agnostic things. All these are nothing but maths at its lowest level and can be implemented in any language for that matter, including JavaScript. So you know this, right? TensorFlow. If you look at right, there is a TensorFlow.js, right? I think it is representational. I'm not sure how effective it is, but people might not use it. There's quite a bit of things are there. The basic operations are at least there. Na? You have sequential, you have model, you know. You also have graphs, so not bad. Okay. So you have ReLU, ELU, all are implementation. See, this is in JavaScript. So if you are someone who can read JavaScript and find Python to be a little intrusive or find Python to be, so just open up any of this code, okay, source, and this is normal JavaScript. You should be able to read it. See how much, whatever way you want to get knowledge, you can get it, not a problem. So TensorFlow has a full-fledged JavaScript, implementation. I don't know how good or bad it is, but I'm assuming that it will not be that bad, right? The point is that if you want, you can actually go back to the source and go more details, get more details. Absolutely, yeah. I mean, absolutely. If you go to the code, there might be a little bit of complexity, but if you're taking a call, so like the simple call, right? Again, if you have reached the first version, you have done first level of backprop propagation. Again, I keep on saying all these things comes in layers, right? You peel the first layer, you have gone gained some importance. Just like you have done one forward pass, then you are ready for the second forward pass, right? You have fixed your weights and biases. Now you are ready for the next forward pass. So next forward pass better be something new. Go to this one. If this is not fine, okay, I will give you one more which is a very heavy. If that is not fine, go to the backward propagation code base. I'm sure that at every level you will gain some important information and then apply it, right? um, if you see this network LSTM, it's fairly complicated network. If to me, it's like really one of the most beautiful things. But it's and that too was done so long time back, right? One cell itself is so much, right? So many things it does, but it is so intuitive and so nice. If you see the code also, I have seen the code. Not that complicated. If you really want to actually learn about RNNs, okay. Again, I think I've shared that thing. Just go through the Chris Ola's. So he was in Google, by the way. Okay, and this is like way long. Okay, and similarly, Amda Karpati has. I will give you these blogs. Okay, Chris Ola's articles are really good. So similarly, if you actually, so what Andhra Karpati has this, he has a, so unreasonable effectiveness on recurrent neural network. If you are really interested to go really deep, so again he did this in JavaScript, by the way, huh? An explainer of how does RNN work at its lowest unit. Pretty interesting, right? And then if you want to stay at a visual level, go to J Almar. Okay, J Almar is a visual artist, sort of, not as in like he was in Hush funding, but now he has a lot of things on language. Okay, a lot of things on NLP. Very good visualization. See these visualizations, like really awesome visualizations. Right? And there's like way to say also is important. Na? I mean, how will we know all those things? Is you have to listen to. So he's one of the very famous. I forgot what is his name. It's transformer or annotation. Sorry, he has a attention. Right? We did a little bit of attention. Remember? So I'm just trying to find out. So he has this also illustrated word to vec, and there was a very famous blog. This is the illustrated transformer. Okay, and everything about attention. If you want to know, right? He has done a very look at the way he explains things, right? Very intuitive point of view. So you can look at all those things, right? So Jay Almar is also very good. Similarly, in YouTube, if you want to learn the basics, right? I said that day about three blue, one brown. You can see this three blue, brown. Go and subscribe to this guy. Okay, Grant Thornton. He is really good. The way he explains it, and he has a backward propagation class. Okay. So again, you can go on what is neural network again and again. So I thought that he has a backprop So there are two videos. Go and look at it. I still look at it. It's good. Every time I look at it, I gain something. Right? There's like, as I say, right? Sometimes if you're lying down, just instead of saying Netflix, you can watch these things. Just helps it. Nothing else. So I'll just give you okay, three blue, one brown. If you're not, not giving you the link, but YouTube channel. This is a very famous. The way he YouTube channel. Okay. The way he explains is very nice. And if you see right, see it's not like 3.5 million views. Okay. Not bad, right? For a backward propagation video, 3.5 million views means it's not bad. In the other one is like almost 2 million views. Not bad either, right? See what is neural network? 11 million views. Apparently, a lot of people are looking at what is neural network. Very interesting. Okay. So look at those things. Information has to come from wherever you want to come from. Okay. What else do you want to talk about? We said that we will look at what are we going to look. We CV this is required if you are doing NLP. I showed you the Google Universal Sentence Encoder, right? The demo itself, right? Glowwig is one more style. Okay. Generative modeling. If you actually do the advanced class, I think they'll cover it there itself, right? So go over the links and blogs and articles, and I have given you some. Okay, some of the things I have given, but yeah, I think if you also go to YouTube and then there is, if you want to know machine learning, right? Or maybe from a take, so just look at Stanford's lectures and MIT lectures. Okay. So everything is machine learning. We are clear, right? Like there is no separate thing. So everything is machine learning. Deep learning is just part of it. So let that be very clear, okay? And yeah, so you can look at MIT's lecture if you are interested in knowing SVM. Patrick Wilson, right? Patrick Wilson. If you are interested in knowing SVM, SVM is very important, right? Patrick Wilson. Sorry, not this Patrick Wilson. Patrick Wilson, MIT. Yeah. So he has a very famous. He's a very famous guy, by the way, in MIT. Look up his videos in YouTube. Okay, and especially on the SVM, it will blow your mind. Okay, even yeah, this will blow your mind. Yeah, it's really good the way it explains. But again, MIT and Stanford will start from mathematics, right? All these things they will have but it's not that bad. It's actually good actually, right? We have looked also at the GPU training. Are we guys clear on the GPU training? Have you? I think I showed you, right? If I'm not wrong, I've showed you. Have you seen this GPU trainer? GPU TensorFlow is coming out. So you can use this. TensorFlow's good thing is that for every page in documentation, they have a run in Google Colab. So you can simply start it or you can download the notebook also. Every page is nothing but a notebook. Okay. That is like really good. We are focused only on TensorFlow here. However, the world is actually for some reason, not for some reason, for good reason only. There's other frameworks also. You should also be aware of that. PyTorch, right? There's a recent, I think today only I saw somewhere, PyTorch is leading now. I think most of the PyTorch is actually leading uh, TensorFlow even, right? So most of the people are using PyTorch. At least that's the survey was saying. Not sure how real or bad it is. So, and knowing two frameworks is better than one. So you can also take that approach, right? We generally, if you are from typical software engineering, you don't know one thing. You know multiple sort of framework. If you're in UI, I don't know if you're in UI, you know React and JavaScript and other things as well, right? Similarly, learn multiple frameworks. The fundamental thing is that you need to build a strategy in a way so that you can learn on your own as well, a little bit. And that is also important for you to establish. Okay. I think overall we are, in a way we are good. You have asked a lot of questions. This batch was very proactive that way. Um, but yes, yeah, I think you have to continue your stride. That is very important. Yeah, you have to have a plan. I mean, overall planning is good. Don't give it up. Is it like, do this on a weekly basis. If you can do it on a much smaller basis, because you not you suddenly one day you can't say that you will be like you will know all these things. You have to invest on a daily basis, monthly basis, weekly basis, at least in small doses, or else it's going to get difficult. Like this is like for anything actually. This is true for anything for that matter, isn't it? And the thing is that if you are like all these things are very important, right? So I'll put it in that community group. I think you guys will have access. That is not a problem. Um, yeah. It Please do it in a regular basis. It will be easier. You can apply all of these things together. That day I saw someone added a very simple library, okay, out of nowhere using this thing. So you have where if you are a software engineer, right, this string equal to check is very common, right? Equal to check, right? You will always do this, right? S equals to string one equals to string two, right? Do you know this, right? So if you are a software engineer, you will resonate. Okay, I just saw that day. Okay, the way I liked it, it's a very common problem, right? If you are a software engineer, you also know that. I'm just telling you guys who are not, is that this operator is not true. Okay, this will, depending upon the language, this operator will behave incorrectly. Okay, so if your S1 is equals to say ABC and S2 equals to say ABC, depending upon language, this will sometimes say it is not true. Okay, this will say it will not true and other ways. Okay? And the other problem is that S3 equals to ABC space. Okay, so there is another problem, and so what this guy has done is that he's created a library which uses exactly that universal sentence encoder that remember I showed you guys, right? So encode this, create a vector out of it, match it using correlation, saying that the match percentage of this two is 0.8, and now you decide. Universally for every language, doesn't matter. In the organization, most of the people are using that itself. It's basically what happens is that it is nothing but a dot. If when you call that API function, it basically internally calls an API hosted inside that intranet itself. So it just completely transforms the whole ecosystem. Now spelling mistakes are and also are automatically being caught. It's very simple operation, very simple thing, right? So this kind of use cases you can build, you can think and easily imply. Right? It's a very simple problem statement. equally appealing solution working for almost across all org, right? It's a nice way to visualize or apply the problems. Okay. Absolutely. So the thing is that my take is very simple. Um, if you are around data like me, or if you are trying to solve problems, right? So the first thing is that if you are in the business of solving problems, there are many ways to solve problems, but I'm assuming that you have already done your software engineering or some sort of engineering, right? You're not a doctor or I mean like doctor as in like human doctor or in the medical field and all. Okay. If you're trying to solve it using tech, every bit of uh, product that I we have been doing, and that process is gonna change. That earlier we used to write lots of ifs and conditions, and you used to build lots of processes to mimic a process, right? And so that is changing. So it's like this example, right? This example, there used to be an algorithm called as Levinson algorithm, a very simple algorithm. Okay, so the algorithm is meet, and it will say that if you do this, right? So it will say that the distance is one. That's a very popular algorithm in string matches, and people who have done it, they will know. All these things are gone now. Simply put, a machine learning algorithm. So I'm saying that the impact of data science and the automation of process is so much that people are using at an equals to level itself. So it has come down, and its usage has increased, and we would need people, right? The industry would need people of various kinds, as well as people who can use these models and deploy. So definitely, this is the if you have a outlook, and if you are in the final year of your BTech, data science is definitely. But since you are in final years of in your BTech, you have a fresh mind. You are not corrupted like me, right? So I would strongly. So you are in second year, good. So I would strongly suggest that focus on your mathematics, okay, and focus on software engineering, okay. So those things are very important because you're not corrupted like me. I have a know-it-all attitude. I mean, I'm saying that because of, see, knowledge also brings corruption, right? You know a lot of things. You have to unlearn. So rather than that, just focus on the basics, fundamentals. I think that will be good for all of us. And if you see what's happening and be in tune with what is happening. We have learned a lot of things about LSTMs, computer vision, and all. So now you see this word floating around called as LLMs. Have you seen this? Huh? Large language models or LLMs, right? So what's happening is that these big tech companies are creating foundational models. Okay, literally foundational models. What they will do? These models are like this Bloom. It's like such a huge model. It solves 15, 20, 30, 40 different kinds of tasks. Like we know that machine learning was solving only one part at a time, but these models can solve 15 things at a time. Okay, one model has can solve 15 different things. So from your point of view, ultimately it comes down to the fact that can you take a part of it and only use it for yourself, right? So that will become a very common sort of usage. Large language models is becoming very rampant in industry because it is virtually not possible for anyone to create these models. Each models will might take 30-40 million dollars to even train. These are such big models, but they can be used drastically by millions of people. and they can solve real problem, right? Google cannot solve all the problem, but Google can build something foundational which can help us to solve many problems, right? They would need people. So that is also the industry is taking one side of industry is you know going towards where even if you have such big models, how do you use it, right? So OpenAI has this OpenAI Gym. Have you know? Do you know, guys? OpenAI Gym, right? So OpenAI Gym is this API, right? It access to your GPT-3 and you can ask for it. GPT-3 is really one of the large models, right? Which can perform variety of natural language tests and codecs, right? And it has been used, so you can use this API to build your own solution. You don't even have to, train a model. You can just use these things. So and a lot of people are doing that in a way. So think about it. There is just not one way to solve problem. There are many ways, and we are seeing this emergence of large language models, um, which I think is a very interesting turn. It's exactly the same turn that I'm seeing right now. That just to use double equals to, earlier we used to think, "Hey, why are we spending so much?" Now all you have to do is just put a model, and that too, that model has someone build it. Okay, not you have built it. You simply copy paste the model, run on inference layer on top of it, you're done, and it is generally faster than anyone else, more accurate. So yeah, I think if you are starting fresh, focus on maths, focus on software engineering. I think it will all be good. We have about 20 more minutes. Maybe you guys let me know what you want to discuss. We have touched upon a large variety of topics. This, if you're starting something, right, this is one of the interesting problem that you can actually solve. If you have to create a brand new neural network layer, okay, how will you do it? Okay. I always ask, someone was asking, right, what interview question you gonna ask? I always give this as an interview question. I mean, my personal suggestion. My it's my personal take is that I always give someone this interview question. That if you have to, about a neural network, create a brand new layer called as my awesome fantastic layer and implement it. Okay, what will it do? It will do XYZ. Okay. Can we submit? No, why just submit the IP1 file, no? Don't submit the HTML file. If someone wants to execute it, na, it will be difficult. So submit the raw file. It is fine. HTML files is just for visualization. You can't commit it. Then someone has to copy the paste code and all. Does not. It will be, it will not be good. So this is one of the interview question that can crop up. Can you implement a brand new neural network layer? Can you do it now? Is a question. After doing this course, do you think you will be able to do it now? And think about it, and then have a structure, and then you should be able to do it. All you need is to have some sort of weights which are initialized. Then you have to implement a forward layer, forward pass. Then you have to implement a backward pass. These are the very core tenets of it. Then the rest is that whatever you want to put, you can put. Okay. Yeah, waiting for more questions, please. Questions are always good. We are coming to an closure of this, but I think last 20, 10, 15 minutes, let's ask questions as much as we can and, get over it. Thanks for that, appreciate it. But I think the course content is good, okay? There's a lot of things. It's actually a lot of things from Simply Learn. But foundation wise, this is actually I like the course material as well. This is pretty good. Alternatively, if you I have to check. I am not sure actually. Is there a way you can actually ask this to the? So I know that there is a advanced course of this. Please ask this to the LSM or your Simply Learn representative. It will be good. I'll be taking one of the courses for the advanced learning. What is that? Advanced deep learning. Yeah. Advanced deep learning with computer vision. Yeah. Yeah. Advanced. Yeah. That's correct. Yeah. So the prerequisite of that course is this. Yes. So we'll go. So that is yeah. So so you understand, right? Little intense. Yeah. Everything needs yeah, yeah, absolutely. So if you are a machine, see all these things, right? So let's go over this code. If you actually see, right, suppose someone you have actually done a pet classification project, right? Or not pet, let's take a real project, right? You see this you see this eKYC. Have you heard of this term called as eKYC? Anyone heard of this term called as eKYC or KYC for that matter? Know your customer. Put a E in front of it. Nowadays, what happens? Earlier, you have to go and open yourself. eKYC is not a is a fact is that eKYC is a process where anyone can open an account. You just need your mobile phone. So an automated system. Suppose you're opening a bank account, bank will call you. The app you in the app you have to show your face and along with your national ID card, right? It will from the image that it takes, it will read the text, read your national ID number, do the verification, check your photo, all the things it will do, right? So this is what application of image processing, the one that you use. It uses CNN networks and all, right? Plus NLP, right? Both are there, right? You have to read the language, whatever is there in the image. From there, you translate it, and then software engineering, right? So all of this is nothing but coding, right? So unfortunately, all of this, why coding? Because unfortunately, computers only understand the language of code, whatever language you write, right? And you need to know coding to do real-time projects. But that doesn't mean the world ends there, okay? If there are other usages, if you already understand this, then you can be a manager or an engineering manager or someone who understands the problem statement part better and understand how one can apply this, but does not necessarily has to apply. He or she can have a team of their own as a guidance, right? That is also there. Business analyst. If you take the role of business analyst, isn't it? So knowing that you can do a backward propagation on a problem statement can tell you that okay, you don't have to know the nitty gritty of it, but gives you a sense of respect, right? Of the process and the how to solve solution both. A business analyst's job is not the raise the problems, also to know a part of solution, right? In fact, the role of business analyst by definition means to solve the problem, right? So you will see that a lot of product managers nowadays are taking the course of not only this visualization tool like Tableau and all, but also deep learning course to get the basics right. They might not need Which IT job will currently affect recession? Hmm. It's a grand question. Um, See, I think overall software is good. Okay, if you ask me, software engineering, software is, now if you are a software engineer, you are king of the world. You understand that, right? The reason is simple. 99% of world is running on software. Software has eaten the world and digested the world also, right? There's nothing else which is running apart from software. So if you are a software engineer, you are already at the generally the percentage of your job security is much higher. If you ask me, okay, from because I mean, who will do that, right? But in any case, recession is a global phenomena. Companies shut down, companies downturn, companies scale down. So that is a case by case basis, right? Nowadays, but overall, I think if you are, if you are a little, if you are a little bit lucky and in the upper 10 percentile of the thing, you're okay. I think. But yes, some of the jobs over more than current recession, I won't comment on the current recession, but when we open GPT-3 and our line says something like this, right? Codex, which translates natural language to code, it tells us something that in the next 10 years, what will happen? In next 10 year, what will happen is that, you know, um, places like manual testing, right? Things like manual testing or all things will get much more reduced and reduced and reduced, right? So there are everywhere there will be impact of this technology. You have to just stay ahead of the curve, and I'm assuming that is the reason you are taking this class, right? I mean, you are in deep learning for, you are teaching yourself deep learning. So, oh, no, Tableau, Python, and SQL is pretty good, right? If you are SQL, which means it's like data side of it. See, all these things, you realize one thing, right? All these things is after the data is there. We have not discussed, or we are not discussing that how do you even get the data. It is assumed that data is there, right? Now, getting data is a very, 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 very difficult problem at a scale, okay? Continuous basis. You have too much abundance of data, but getting right data is not easy. So SQL, Python, PySpark, Apache Spark, or all those things are, you know, are data parts of it. So if it is hard for you, move to the data side of things. Okay, data engineering is a huge field. Okay, huge field. It's almost so data engineering is a massive field on its own. Okay, and it requires a lots and lots of. So Simplilearn also has a data engineering program. Okay, so you have big data engineer, not this. Okay, so data engineering is a huge field. So I think this deals only and only with data, and you will see that uh, there's a lot of work, and Tableau is nothing but visualization. So many a times you don't need to know what is happening; you just need the output, na? And trust the tool. Yeah, so criteria from our point of view, I think you already tick the criteria. You already have Python. If you already know SQL, you're already doing a part of it, right? And there are other tools to ensure that data is in a feature format, right? Data is correct. You will be focusing on the EDA part of it. Remember the EDA, right? This part, the first part of it. Yes. So that those parts of it, right? You are ensuring that the data which just goes to the model is perfectly fine. Not only that, at scale, billions of data points. You are generating an IoT system. You know what is an IoT system? Internet of things, right? So IoT systems are extremely, extremely high propensity data, right? Billions of data points per second, right? So that at that scale, data coming and at that scale, data coming and you know cleansing it and making it for machine learning model requires a different skill. So you need big data systems, visualization. Voice is not coming. Hello? Can you not hear me? Hello? Okay. Right. So you need big data systems, right? Really large data systems. So look at this specific field of data engineering, and there are a lot of tools and techniques that we have not discussed because we have assumed data is there. Everywhere someone has given in every example and everywhere we have assumed data is there. How has data come? Nobody has bothered, right? At least in this class. So data engine is the guy that who will tell you that how the data was created, acquired, collected, pruned, right? So that's also a major part. Okay, there's a lot of tool tricks, software engineering effort. You can look at that. That's also a pretty good area. Okay, this is a very large field. It's almost encompasses software engineering, guys. This data science plus machine learning plus artificial intelligence systems. So this is a very broad area of things. And the only unfortunate thing is that nowadays this data scientist role is so, I mean, this is my personal opinion, the expectation from data scientist role is very weird, okay? And they are looking at 10 different kinds of role in one person. That is not possible. So being a realistic is also important, right? So I think we will see some more maturity as the years go by. And but yeah, data engineering is a very good area of interest. Oh, absolutely. Yeah, absolutely. That is very important actually. Some things you have to give up. Some things like I knew that I could never become a doctor, so I gave up. As in, like I didn't take it. So like that, right? Uh, so yeah, it's difficult. It's difficult to, but yes, the only good thing is that you if you keep that hat of can you learn, can you teach yourself anything? So only the machine learning has taught me one thing is that if you have your weights and biases appropriately done, and if your forward pass and back pass is ready, you can teach yourself. Okay, maybe not to the topmost level, but at a some level. All you need is that initial kick. Initial value is nothing but the motivation, right? So that is very important. Okay, continuous to learn anything. For data scientists, which are important, for a data scientist, yeah, you need to understand data. See, data scientist by virtue means data scientist. Okay. Now we are trying to put all things there. So you have to do EDA, you have to do model building. Okay, and so on and so forth. Different companies will have different ideas, but generally, data scientist plus machine learning engineer depends on where you are getting hired or called from. Basically means from your data building, from your data to feature engineering to your model building to your evaluation to your production deployment. Okay. In some cases, data scientists, like in my company, data scientist stops at the time of they don't write production ready code because they can't. I mean, it's difficult, but they are very good at presenting what needs to happen. They can formulate the process, which is difficult for a software engineer. A software engineer might not know, or a ML engineer might not know the actual process, which feature to use, what it means, and so on and so forth. But if it's new, then it's good, right? So your slate is clean, right? Which means that you can draw any picture that you want, right? And it's just a matter of trial and error, right? Again, machine learning will teach you one thing is that hundreds of forward pass and backward pass makes you a master, not one, by the way. Huh? You have to run your epochs. There is no other way. You have to run your epochs. Good thing is that you are already a human being. You are not a machine. You are already intelligent. So that way, at least you have a good kickstart. So what I meant is that your initial weights and initial biases are already good. So you have a very good platform to build anything on top of it. Okay. All right, folks. Do we have any other questions that we want? I will share this. Okay, in my community link, and you can drop a message. I think, yeah, on that we'll figure it out. I can always respond as much as possible. I can share. It's like if you see this, I'll see this. This is my LinkedIn profile. You can search Sandeepan Basu. I will share. I have shared all the files actually, isn't it? In there, if you just go to if you go to the community link, I have shared all of it actually. Whatever we discussed over the course of this thing, I have shared all of them. So let me just. So just you see this thing. It's basically it's not advisable to share personal things, but since you have asked for it, this is what it is. You can write it down and you can share it. Not a problem. We can always connect. Thanks a lot, folks. Appreciate your patience. Um, that's correct. Yes, yeah. Leading risk and insight. That is correct. Yes, absolutely. I will send it. Yes. Forward, Bravo. I have to send it, right? You just hold. Shishankar, let me. I just presented it. I will share it. Don't worry. By tomorrow, you should have it. Okay. No worries. No worries. Yeah. 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 Please go ahead, Shobha. Thank you, folks. Thanks a lot. I will do that. I will do that. Yeah. Shobha, you have a question? Oh yes. Oh, I have. One of my professor. I won't name him, but he has done his BCom, and then he was in market analysis for a long time, and he's one of the best data science and machine learning teacher that I have seen. Okay, literally, I'm not joking. So yeah, I mean, a lot of non-IT people are there in data scientist. Okay, as data scientists, they have picked up because of the fact that Python is a easy language to pick up. Okay, and all these things goes back to the fact that you don't need to know coding. At one point, if you see, right, coding was the privilege of software engineers. You have to know a specific language, this, that, whatnot. But now it looks like Python is very simple. All you need to know is high school mathematics. And sometimes you also don't need to know that because Keras is abstracting half of it, right? And then if you don't want to do that, you can focus on the data part of it. So I have a lot of people who are there in data scientists who are not in IT, no, not from IT. This will require a lot of places, right? Lot of things. And yeah, all you need is a little bit of motivation to. Thanks a lot, everyone. Starting from a data would be internship. If you can do internship, then nothing like it. Actually, nothing like it. Absolutely. If you can get internship at an early, when you initially your starting years, best place to learn. And try to find a startup. Not, I'm not against any other company. Yeah, awesome. That is really good. Try to find a startup because my suggestion is that if you have to learn a lot in 2 months, what best place than a startup? Of course, if you get into Google and Uber and all other things, that's a different thing. But just to, yeah, exactly. So you'll make something out of that 2 months of your time, 1 month of your time, right? Yeah. Your objective should be you have to optimize your time, right? Yep. All right, folks. I think that's a great batch. I hope you guys well, and I'm sure that our paths will cross. Thanks a lot. Um, you know, thank you very much. Thanks everybody. Okay. No, no. I think the fundamental fact of the matter is that do it in small parts, run many epochs, do it in small batches. Okay. That's very very. Do you impart only Keras or other mode? No, I know PyTorch also. Yeah. In fact, if you see that there's just PyTorch was actually leading TensorFlow. So PyTorch is also very famous. Okay, folks, let's call it a day. Thanks a lot again. Hope to we'll definitely cross our paths. Thanks a lot. Thank you very much.